So before I'm going to start, I would like to ask you a question. Just take a guess. How many smartphones does the average person in the US have? I would love you to raise your hand if you say it's one. How many smartphones does the average person in the US have? Is it one? Is it two? How about three? Four? Okay, surprisingly, it's 1.7. And believe me, all of these smartphones are filled up with AI. And this is... So I'm here for Siemens Healthineers, and my name is Dr. Victoria Schneider, as already mentioned. So, and I would love to tell you something about not only about the photon counting, I would round it up talking about lung cancer screening and, of course, the AI. So talking about photon counting, there's a proven impact, for example, for the neonatal alpha in clinical routine by expanding the reach, reshaping diagnosis, but also guiding therapy decisions with clinical insights. But I would love to share some quantum results backed by clinical evidence. So have you ever struggled with subtle lung features and diagnosis? Believe me, you are not alone. Precision is key, especially for ILD and UIP. And quantum HD has less radiation and enables a sharper ILD diagnosis. It also offers ultra-high resolution imaging with reduced radiation exposure. And it enables the execution of ultra-low dose CT with X-ray radiation while maintaining high precision managing. We commonly agree that lung cancer screening itself saves life and also helps to reduce health disparities. So here are the results. Wait. Here are the results of Poland. And it clearly shows that low-dose CT itself offers more than just cancer detection. It also improves survival rate. It also improves survival by addressing cardiovascular risks. And the magic lays in the detail. Lung cancer screening also helps identifying interstitial lung abnormalities early. Within this UK study, there has been 3.9% prevalence of ILAs in the lung cancer screening cohort, with 40.7% developing ILD within 5 years. And 1.6% of the cohort has been diagnosed with ILD. And this is the same rate as those diagnosed with lung cancer. I would like to round it up and talk a little bit about the OSIG. OSIG is short for Open Source Imaging Consortium, and it is part of advancing ILD research. It's a global NGO uniting experts for better insights, and now it also includes the Croatian program of national lung cancer screening. And there's an upcoming competition. OSIG is going to focus on AI tools predicting who is at risk of developing ILDs. And talking about AI. There is a significant amount of AI applications released every year, and it's significantly increasing, as you can see over here. And I know, honestly, we are part of the problem, for example, like Siemens Healthineers. I know, because we are the ones actually helping to develop those algorithms and submitting them to the FDA for clearance. We do have over 100 applications from cardiology, over radiology, oncology, and more. And over 50% of these applications are powered by AI. So with more on the way. And there are definitely challenges. You know that better than me. Legal frameworks, installation methods, setup processes, and workflow differences pose significant obstacles. The key issue is to despite the vast number of applications, and these barriers need to be addressed for smoother integration. And we do have a solution. It's called Single Carbon. It's an AI-driven diagnostic within 3 steps. Number 1, unified patient data model. Number 2, access at curated apps for testing. And number 3, integrated platform for analysis and diagnosis. And the imaging value chain represents our internal process, guiding everything from patient history to final diagnosis. But how can we expand the use of this patient data and make it more meaningful? So we know the patient is not only a number. This is a lot, I know. Here you can see the data for one single patient within oncology. It includes images, treatment plans, blood values, and much more, and is full of underutilized data. And within the next slide, I would like to show you some few prototypes we're developing right now to make a better use of these data. And here we are. So with the existing data, we can optimize scanner and assignments for each patient. And we optimize those scheduling, for example, with the Neotom Alpha. It's faster, it has no delays, for example, finding out about any other diseases, and it's consistent in results across scanners with comparing the growth of with optimized protocols. And if you can get back to the same patient, for example, it makes the whole process of comparing the growth of the nodule much faster. So nodule tracking itself and automated tasks enhance diagnostic accuracy and workflow efficiency. And we are always talking about precision medicine, precision therapy, and patient training. And to make this work, you need all of these 3 pillars: patient information, AI tools, and of course, intelligent scanners. But the most important part is actually the backbone, the IT infrastructure behind it. So let's think big. And here is my conclusion. Thank you very much.